Okay, grade 11s, as promised, we're going to work through an exam question that's based on diffraction. And the question we are going to look at is a question from November 2019, paper 1. It's the exemplar paper. So please go to your learning paths, your groups, and then from there on, paper 1 for the exemplar. So very first question, as always, you know, when the questions are asked, they will ask you a theoretical component and then application. So with the theoretical component, question 7.1, it is the law. State Huygens principle. So every point on a wavefront serves as a point source of spherical secondary wave that moves forward with the same speed as the wave. Now, we talk about the wavefront, we talk about wavelets, remember that as well. So yeah, this is basically 7.1, but you can study that, you don't have to, you don't need me to write it down. The one I want to talk about is 7.2, 3 and 4. So 7.2, it says the following: blue light is viewed through a narrow slit. Draw the pattern that can be observed on the screen. So first of all, you will have to show the pattern. You don't have to have a neat pattern, just make sure it is represented as follows. So there will be a few pointers. And this is basically it. You'll have the central band, which is that one, and then you'll have dark bands in between the color bands. Now obviously in a test you will not be able to have different colored pens with you, but in this case you will have, well, in my explanation you can see I have a colored pen. Okay, what you will be marked on, what you will be assessed. Now this was a 3-mark question. Your first mark will go towards the central band, and they basically going to look at it and say, is your central band broader than the others? 1 mark. Then the second thing they're going to look at is, are the other color bands more narrow, and if you know, than this one, and that will be your second mark. Third mark is, do you have alternating dark bands, and that's the third mark. That's basically the memo for this one. This was 7.2.1. So now let's look at the next one. Now they ask you, explain how the diffraction pattern is formed. Now you can just say the bright bands or colored bands are formed due to constructive interference, and the dark bands due to destructive interference. So you will have to refer to the different aspects of this: due to constructive interference, due to destructive interference. Then number 3, it asks you, the slit width is now made smaller. How will the degree of diffraction for the second slit compare with that for the first slit? Right? Only greater than, less than, or equal to. Okay, so remember I told you diffraction is directly proportional to the wavelength and indirectly proportional to the width of the aperture. So what's taking place now? The width is becoming smaller that means diffraction has to become bigger. So therefore this answer is just greater than. Then 7.4, a blue light is replaced with red light. How will the pattern formed by the blue light compare with the pattern formed by the red light? Remember now we are talking about wavelengths. Okay, so blue light will have a shorter wavelength. So therefore the central band for red light will be broader than the central band for blue light. So that's the first thing that will take place. So now, I said, blue has a shorter wavelength than red. Red's wavelength is longer, so the wavelength is now made longer. That means the degree of diffraction will increase because the wavelength is now being increased. So if we look at this again, this central band will become broader, and these will move out a little bit. It will become further apart because the degree of diffraction is bigger now because of an increased wavelength. So that's it. That's basically how this question will be asked in an exam.